Hello programmers, in this video we are going to discuss about the difference between repartition and Coalesce in Apache Spark with Scala. Let's see what is repartition and Coalesce and its difference. Both are very expensive operations as they shuffle the data across many partitions, hence try to minimize the usage as much as possible. By default, Spark shuffling partition size is 200, and if you want to change, we can change in the configuration and the key called spark.sql.shuffle.partitions. Fine. Let's see the major difference between repartition and Coalesce. With the help of the repartition, we can able to increase or decrease the partition, but in a Coalesce, only we can able to decrease the number of partitions. In a repartition, the partition data are equal in size, but in a Coalesce, the partition data are unequal in size. Now, with respect to the performance, repartition is less performance when we compare with the Coalesce, but Coalesce is better performance when we compare with the repartition. And final important thing, so unequal size partitions are generally slower to work when we compare with the equal size of partitions. Fine, let's get into the program, and you can see this simple Scala object. This is a simple main function. Here I just restricting the 10 of the Spark info logs, and here I just creating the Spark session object with the master as a 5 core, and I defined as a local array of 5 just to demonstrate the repartition and Coalesce. And here I just creating the Spark data frame with the it's having single integer column and the range from 0 to 40, and its header is unique ID. Here I just display the same, and here I just displaying the number of partition before we start using the repartition and Coalesce. Fine, let's see the repartition. And I'm going to start with the data frame dot repartition. So with the help of the repartition, we can able to increase or decrease the partitions. Now I'm going to increase, and I'm going to assign to some object, and now I'm going to find number of partitions after we call the repartition function. And to calculate the partitions, either we can use dataframe.rdd.partition.length, or we can use rdd.getNumPartition. Both will return the same result, and I'm going to use same for the Coalesce as well. So with the help of the Coalesce, we can able to only reduce the partitions. Now I'm going to reduce to 4. And I'm going to calculate the partitions. Fine, I'm just going to run the program. Let's see the result. Fine, it's got completed, and here you can see that initial value is 5. So because we started using, before we start using the repartition and the Coalesce, the partition size is 5 because we defined the master core is 5, and the repartition is 8. So after we call the repartition function, and now the partition size is 8. And also you can note the rdt.partition.length and rdt.getNumPartition will both are same value. And for the Coalesce, so it has decreased to 4 partition, you can see. And also for partition.length as well as the get number of partition, the result are same. Fine, now I'm going to find the how many data available in each and every partition. Let's start with the repartition dot with the column. Just going to create a simple column. Just for each and every partition we have to define some name, right? Here it's going to define named so partition ID, and we can use some assign some unique number with the help of Spark partition ID, and then going to do the group by with the partition ID and dot aggregate, then going to count how many values present in each and every partition. And here I have to copy and paste the source column name, and here I have to display order by just display the record. That's all. And order by, we have to say which column, and order by partition ID. And similar thing I'm going to repeat for Coalesce as well. Fine. I'm just going to run the program. Let's see the result. Fine, it's got completed. So let's start with the repartition. So we can see there are 8 partition available, the same number of partition, and all the partition having equal number of values, 5. And for the Coalesce, we can see only 4 partitions, but the data in the each and every partition are unequal, and due to when we call the Coalesce function, the data will move to the nearest partition. So here it moved to the 4th partition. Fine. Now I'm going to write the data in some file. Let's start with a repartition dot write dot save. So here we have to define the file path. Now I'm going to define some folder. And another important thing, here I not define the file format. So if I'm not define the file format, the Spark will write the data in snappy compressed Parquet file format. And the Coalesce going to write with some file format, just to demonstrate, going to write it in CSV file format dot save in. So here I'm going to save. Fine, and just going to run the program. Let's see the result. Fine, it's got completed. And let's start with the repartition. And the data are available in partition ID folder. So here is the folder. I'm going to extend the folder. Let's see briefly. So here you can see I didn't define the file format, so Spark will write automatically all the data in snappy compressed Parquet file format. Let's count the files. 2, 3, 4, 5, 6, 7, 8. Here we have 8 files due to we have defined the repartition is sizes 8. And next we will see the Coalesce. So here it is in CSV file format, because while we use the CSV file format while we write the data, and the number of files is 4 because we define the number of partition in Coalesce is 4. Fine, that's all about the repartition in and Coalesce in Apache Spark using Scala. If you have doubt or clarification or any suggestion, please share in the comment section.